Welcome you to my channel. This is next second video I'll be doing here, and again I showed up to you that I promised that I'll be solving problem until I get in big tech. So today we are solving the other question of tree, that is subtree of another tree. So what will be given? What I'll be given? I'll be given a two binary tree, root and subroot, and return true if there is subtree of root which is the same structure of node value of subroot, another false otherwise. A subtree of a binary tree that consists of node in tree and all the nodes descendant. So what is saying that we will have a root, we will have a subroot. I have written true if subroot have subroot, or structure if there is subtree of root which with the same structure of node. See here, remember this, there is subtree of root with same structure of node and value of subroot, right? Otherwise return false. That is the problem statement I have to solve. So let's solve this question, and what how to solve it. So to let me open a blind paper, sorry, Google Docs, yeah. Hmm. So I will have a tree like this. I will have a tree 3, 4, 1, 2, and 5, and I will have subtree 4, 1, 2. So how will I find how I am going to find that this 4, 1, 2 is subtree? So if you think simply, 4 is the part, right? 4 if some node have 4, I'll assume that the subroot start from there. If some node has 4, I'll assume that sub this is the main point. Uh, if some node is there, if some node if a node have value as subroot dot val, then I will assume that uh, subroot I'll assume that if node have value as node dot value is equal to node value node dot val is equal to subroot dot val, then I will assume that subroot start from there. Subroot start from there, right? 4 is 4 4 start from there, 4 to 4 1 2, right? If both nodes does not like if the I will assume that. So one point here I'll consider key, what if there are multiple same root. We can have we can have here point one more edge case. We can have multiple node with same name with the same uh, value, multiple node with same value. No worry, I had to find only one that have subroot, right? If multiple have also, if multiple have also, no worry, but I have to find. So see here, I was solving this problem, I got caught here. Here one, and this is the list, this is the list one, sorry, this is node, and node is pointing, one is pointing to one, and here I was returning false because I was checking for only first, but second is also there, and this is a root node basically. This is root node, and we have subroot only one. So you got to see here we have one, but we have structure is not structure is not equal, right? For root one, we have child of that root, right? The structure is not matching. So what I'll do here, I will find all the node which have subroot, which have a value that is equal to subroot dot val. You have got my point, right? Root means there is chance that we find the node, root node, which have which a value which is equal to subroot dot node, but that structure of that particular root or subtree I would say is not equal to subroot, sorry, right? Like here we see 1 is matching to 1, but the structure of 1 is not matching to 1. Why? Because this one has descendant, but this one do not have its descendant, right? So this one do not have descendant, that's why this first root will return false, but we have other node with same value, and the structure of this is also same as subroot, right? Because the subroot of this one do not have any value, right? That is the problem, that is the thing. So what I solve when I solving it, I thought that I assume that there is only one, there will be only one node which has the value, which have same value as sub which have which have same value as subroot dot val, right? But I was wrong, we can have multiple, right? So what we can do here, first let's find out how all the roots to which have this value 4 or 1. So I'll try to find here, let me write here, I'll try to find all node which have same value as root dot val or subroot dot val. Right, I'll try to find all the node which have same value subroot dot val. And then what I'll do here, find the I will check if subtree both the tree is equal or not. I'll check if both the tree is equal or not, right? Let's say I'll find 4, a subtree of 4 is 4 1 2 4 1 2, both are equal, right? Right, if one of them is if one of them is satisfied, I got my answer, correct, no? So let's write the first point first. I'll try to find all nodes which have same value as subroot dot val. So let me find it. Definition: all nodes. The name of the function is all node. Here is self. Self is basically pointing to this class, and this all node is defined in this class. This is self. This is self. Now we got root, right? Only root, right? And we got value, right? Now what will happen that I have to find all the node which is equal. So what I'll do here, I'll define a queue or a stack, whatever stack. Order doesn't matter, just matter the node. So stack will be defined as root, and then I'll do here scene. So if I'm traversing again the same node, we do not have any same value, right? And I will check while a stack is defined. What I'll do here, I will pop it. So node stack dot pop stack dot pop. If node is equal to stack dot pop, I popped it, right? If node dot val is equal to value, and node dot val is equal to value, and um, node id of node not in stack or scene, id of node not in scene. What I'll do here, I'll push that scene dot add append add node, and what I'll do here answer list. It will return list 3 node. List dot append node, right? Else uh, a list add a stack dot if node dot left stack dot push or append node dot left. If node dot right, same stack dot append node dot right. Now I got the list, return the list. So here I got the list, all the list that is defined, uh, all the list I got, sorry, list of all the node which value is equal to the this 4, or like given this 4, right? Subroot of the subroot value, correct na? Now what is my next point? Next point is this. Next point is this कि I will do DFS to find if root if tree is same or not. So DFS is root it is tree same. This is a node self root 1 or R1 or R2, and it will return boolean. So if not R1 and not R2, return true. Otherwise, when I will going to call it. Otherwise, if one of them is also, if R1 and R2 exist and R1 dot val not equal to R2 dot val, in this case also I return false. If both the cases satisfied, one more thing na, if one of them, if not R1 and R2, if R1 is defined and R1 is not defined, R2 is defined, and or not R2 and R1, R2 is defined, R2 is not defined, but R1 is defined. If both the case is true, I return false. Otherwise, return is true, is tree same, is tree same, R1 dot left, R2 dot left. and is tree same r1 dot right comma r2 dot right. Right, now that's it. I'll call the all nodes to get all the nodes list. Root comma subroot dot val, and there is chance that I don't have if node not subroot, return true. if if not if not root and subroot is defined, return false. Right, if subroot is defined but this root is not defined, I will return false. Right, now again I got all nodes. What I'll do here, I'll loop it. So for I in range nodes list dot length, or length of nodes of list. For I in range length of nodes list. Hmm. if if is the same जो नया रूट होगा nodes list of I comma subroot. If not return false. चाहे if I got 1 point, return true, otherwise return false. So that is the code what I have written here. So first the code what will do here, it will try to find the list of nodes, right? Then it will basically a last question answer, key finding the tree same or not. And this is and this row number 42 is just we are trying to find, trying to loop and call the function is tree same. That's it. So let me verify one more time. So stack, we have defined a stack which is taking the root of the value, and scene set to check if we don't have duplicates. Right, if there is no root, if not root, return empty list. Right, otherwise I got the list, I got the stack set to check duplicate. See, and this is the stack is not empty. I got the node, if node value is equal to value and id of node in the scene. I have asked this to the list set, and I have also add node into the list, right? And now we are just updating the stack node dot left node dot right, right? Now second is the if both are true. If not r1 and not r2 means r1 and r2 both are not defined, I will return true. Means this is the base case, and this is the case where we assume that we have traversed the whole r2 and r1, and we have find the structure of the r1 and r2 in that particular section or like left or right, it is equal. That's why it's true. If r1 and r2 both are defined but r dot value is equal to not equal to r2 dot value, I will return true. If return false, right? If not r1 and not r2, r1 defined but r2 not defined. If r1 defined but r2 not defined, and r2 defined, r1 defined but r2 not defined, and r1 not defined but r2 defined, I will return false. So there is three cases where I am returning false and one case. So there is two cases I am returning false. There is one case I am returning true. Right? And now I'm just looping here. If not subtree is return true. If root is not defined but subroot is defined, then again return false. And here I got the list. I'll loop the list, and I'm not calling function here. If same tree. So if self dot, one thing I just missed, self dot. Calling the same function, I have to use self dot. If self dot is the same, nodes of I is equal to subroot, return true, otherwise return false. That's it. There's something indent problem. Yeah. Sorry. All nodes is not defined. Okay, self dot all nodes. Self dot all nodes. All nodes. It's not node. It's nodes. Yeah, it passed. Now let me submit. Now you see here it failed here. There's some mistake I'm doing here. What is length in this case? Length is 1, but it's 2, right? We should have 2 here. There is some problem in all nodes section. If node dot val is equal to value, I will add this scene dot add id comma node and match dot append list dot append. If node dot left and node dot right. So why is lambda? There's some mistake I'm doing here. I don't know. While stack dot pop node dot val is equal to val scene dot add id and match dot append node. So release dot append node. If node dot left, I'll append the node left. If node dot right, I'll append node dot right. And at the end, I will return matches or I will return list. It's correct only, right? Self root comma value. My code has some problem in this area in all nodes only, and I'm not able to figure out why. But let me understand कि सबसे पहले हम root बनाएंगे. If root is not defined, I will return empty array. If root is there, I'll create a stack of that root. Seen if node dot, I'll pop the stack, right. I pop the stack, and here I'm pushing it. If node dot left is defined, so if I visualize it, so node dot left is defined. Stack dot push node dot left. So can I print here? Print node dot left dot val. For this case, it is coming up, right? Node dot left and node dot value. List dot append. Oh, okay. I'm saying that duplicate node, not ID. But let me check this. I write like this. What I have? Still. Okay, how many times we am popping it? Print node dot val. Two times I'm popping it, right? Okay, is there any chance I may encounter duplicates? No, right? Let me just don't add it. Print li dot length. How is it possible? Its length of the list should be 2, right? If node dot val is equal to val. I don't know what I'm doing wrong here, but I have to figure out. So it's coming up twice here, you see? It's coming up twice and we are appending in 2 times. What is wrong then here? Node stack dot pop if node dot value is equal to value, and print node dot val and list dot append node li dot append node dot left node dot right. Why length is 2 only, yaar? Length is 1. Here you are appending the list again. Can I print a line? Let me ask ChatGPT what is wrong here. Okay, saying that okay, always explore the children. Yeah, always explore the children. If not that, if not there, always explore the children. Correct. Correct. I told right this is the problem. What I doing was doing here. If node that value is equal to value, I will appending the list and else. But I want to insert a child of this node, right? And that was the problem. It was not being inserted. Correct. Now, one thing I was looking into the code. I noticed that we can eliminate this part, this code, and we just write here. Key. Uh, Here, if this one is true, if self is same, then return true. Otherwise, just call the same function, uh, self dot, call the same function is subtree and root dot left comma subroot or self dot is subtree root dot right comma subroot return. And using this I will just eliminate this node list part. If not true, if subroot is not defined, I return false. If subroot is not defined, I return false. If subroot is not defined, I return true. If root is not defined, I return false. And this will take, it will check. So basically this will eliminate this is all node definition. There is indentation problem. Hmm. Yeah, this is the thing. So why I have done not, I have removed the dependency of all nodes. So we don't need node list. I'll just need root. I'll just need root. Yeah, passed. Right? Yeah, it was very interesting question, and I tried to solve. I solve it using two way. First, finding the all nodes, and then check the tree same or not. And second is that call recursively, right? And yeah, it worked. So let's meet tomorrow, and I promise that I will show up all daily and try your job. So be consistent. I'll be consistent. I hope you will also be consistent. Thank you so much. Thanks for watching.